It looks like we've already done this, doesn't it? Graphing systems, right? We graphed systems, didn't we? First, wasn't that the first thing in this chapter? But what's the difference between this and what we graphed earlier? They're inequalities, okay? So it's not equal to, it's what?
It's not equal to.
Well, yeah, it's true. But it's less than or what? Greater than. Or less than or equal to and greater than or equal to. All right, so let's do one. I'll show you. It's fine. If it was, believe me, I don't really like it hot in here, so if it was hot, I would know. All right, so here we go. We're going to start right off with an example. They don't even teach anything before this. They just start off.
We want to have smartwatches on.
I don't know. Quit ratting on people. All right. So here we go. 3x plus y. Look at the difference. Shh. Let's put your attention up here. All right. You see the difference between this and what we did in the first lesson of this chapter? You got, the inequalities, okay? And that changes. It really doesn't change. Well, it changes one little thing on how you solve for it. Depends. I think you know what I'm talking about. But the graphing changes too. All right, it's kind of the same, but it's different. All right, so what we're going to do is this. Okay, we are going to change this into slope-intercept form. All right, so we're going to get y by itself. We're going to graph it, but then we got to look at it. Now, there is, and we've talked about this before, I believe, didn't we? Haven't we graphed an inequality before? I think we have, right? Just single inequalities. What's the only time where the inequality has to change? Right, if you multiply or divide by, or what? A negative. Okay, then you would change this. If you don't have to divide by a negative, then it doesn't change. It stays the way it is. All right, so let's do this. We should probably do this in our head, right? Get y by itself. What do we do? Subtract a 3x, right? All right. Did I have to change the inequality? No, because all I did was subtract. Subtracting and adding, you don't change the inequality. The only time you change it is when you multiply or divide by a negative number. We didn't have to do that here. We might have to do one extra. I'll do this step right here. Okay, so 3y, get rid of the x. So it's negative x minus 6. And then do what? Divide by 3. So divide this by 3, divide this by 3. Do I change the inequality? I divided, but I didn't divide by a what? A negative. All right, so I don't change the inequality. It stays exactly the way it was. So here's my other one. So y is less than, what's that? How do I write that so it looks like slope-intercept form? Yeah, negative 1 over 3. That's how I'm going to write that, and then put an x right there. Yep, and then minus 2. Okay? So this is what we're graphing. Everybody good so far? Yeah, nothing new. It's Algebra 1 stuff. And we didn't even have to change the inequality, so that was nice. Okay, eventually you will at some point, but you didn't have to here. So let me grab a graph. You don't have to have graph paper for this, but it's kind of nice if you did. Let's put that there. Let's make this pretty big. That's good. And let me grab our two inequalities, put them next to it so I remember what I'm graphing here. And then do this, do this. All right. Oh, goodness. Who's calling me? I'll call him later, I guess. Okay. So this is what we're graphing. All right, so let's do one in red. We'll do the other one in a different color. So plus 4, 1, 2, 3, 4. So the first part of this shouldn't be a problem. Really nothing, we haven't really done anything new just yet, have we? And to tell you the truth, there's not a whole lot new to this, right? Have we graphed inequalities? Yeah, just a single inequality. We'll do the shading, remember that? Yeah. So really what we're doing today is not a whole lot different, except the last problem, all right? But it's really not a whole lot different than we've done before until you get to the last one. What is this? Negative 3, 1. So 1, 2, 3, 1. I'm going to do it a couple times. Do you find yourself doing this? Putting a couple points in there instead of just going 3 down and 1 to the right? Then I'm going to go to the same thing up, though. 1, 2, 3, 1. All right. Just make sure, it makes sure that my line, is going the way I want it to go. Because if the points are too close together, it's hard to tell if you've really got your line the way you want it. All right. And let's do this one. Negative 2 is the y-intercept. And the slope is negative 1/3. So I go down 1 to the right 3. 1, 2, 3. Let's go up 1 to the left 3. 1, 2, 3. That's good enough for us. Connect them. And then connect them. Boom, like this. All right. There we go. So we drew the lines as if this was just an equal sign. Agreed? Oh, there's one thing I should have done. I'll tell you what, let's do this. This is my blue one, right? Since I have the ability to do this, might as well. Can't do that on your paper, but it's all right. There's a little bit of a problem, though, with the blue one. It should be dotted, that's correct. And I really wish there should be, there should be a dotted line thing. Let me see. In this other program that I use, like to make up the quizzes and tests on, there should be, I bet you anything that there is, I just don't know where it is. Style? No.
Yo, you're digging in it.
It's not that. Is it one of the? No, it's not any of those. See, it seems like it would be in one of these drop downs. Guys, just because I'm taking a second to go in a different direction doesn't mean it's free time. Have I not said that like 100 times in this class? So let's just pay attention. All right, just watch me flounder a little bit. Let's see. New brush, select on. See anything that looks like it would be dotted? There has to be a dotted line, but I don't think I can really erase once I make a line like this. If I was like freehand, I think I can erase it, but I don't think I can when it's a line like that. But I don't know. It might be an idea, so let's give that a shot. Eraser. Is that my eraser tool? Nope. Do I even have an eraser tool?
Right there under the paintbrush.
This thing?
Yeah.
Eraser tool. Okay. Let's see. I'm going to make that a little smaller. Let's see. No. Oh, yeah, it does it. Well, that's cool. Oh, then erase that thing. That's going to be a pain in the butt. So I'm just going to go old-fashioned way and just draw it by hand. All right, so what is this? 1, 2, 3. So, what? Yeah, well, I warned you. All right, this is ugliest. That's a terrible line. Looks like I've been drinking or something. And I don't even drink. No, I've never had a drink in my life.
That's not true.
It's absolutely true.
Isn't there a picture on your wedding day?
Why
Didn't have champagne on my wedding day.
What?
I've never had a glass. I've not had one sip of alcohol.
You ever drink alcohol like at communion or anything?
Okay, do you hear what I'm saying? Listen to what I'm saying. I have never had a drop of alcohol in my life. Doesn't matter what the situation is. I've never had it. Never.
Hand sanitizer is good.
All right, so let's take a look. So, I mean, I'm not saying that to brag. It's just a fact. That's all I'm saying. It is a good thing. It's a very good thing. Is that why I look amazing? I didn't know I looked amazing. All right. Yeah, thanks a lot. Not quite. I'll be 60 in January. Though. All right, let's take a look at this. So it says y is less than. Everybody look. Look at the red one. Y is less than or equal, right? So where is the less than on this red line right there? Where am I going to shade with the less than? To the left. That's right. Now, if you wanted to, this would be a little extra work for you. It's not much work. But you could put 0, 0 in, right, just to see if that was a point. And if I put a 0 in for that, that's 0. Put a 0 in for that. Is 0 less than or equal to 4? Yes, it is. So that means anything on that side of the red line would be shaded in, correct? Now, I was watching a video today of a guy that was doing something similar to this. It wasn't exactly this problem, but it was very similar. And he like shaded everything in, and then he took another, he didn't have colors, he just did it on a whiteboard, but then he shaded this in, and then they saw where they overlapped. I guess you could do that, but I think we can do that in our head. Look, so everything basically below, if you want to call it that, or to the left of that red line is going to be shaded in. Would you agree? So like everything over here is going to be shaded in. Okay? What about the blue one? Everything what? Underneath, right, below the blue one. So it's got to be to the left or below the red one, below the blue one. So where is that? Where is the shading occurred? It's just this. Agreed? Because it's got to be in both of them. All right? So now I can go wild and shade it. All right, so all that stuff right there should be shaded in. And that's your graph. That's it right there. Okay? That means what? What does it mean? That means any point where I've shaded in yellow, I could put that point in for X and Y, and it's going to work for both of them. Everybody see that? Yeah. Okay? So, for instance, let's just try one, just for fun. What's an easy one? Let's go 0. Let's go 0, 1, 2. Let's go like 3, -3. Is that all right? Would you agree that 0, -3 is inside the shaded area? Yeah. So let's just try it on both of them, see if it works. So X is 0, so that's 0. This is -3. Is -3 less than or equal to 4? Yeah, it makes that work, doesn't it? Let's put the same point in for the blue one. Put in a 0 for the Y, so that's 0. I'm sorry, 0 in for the X, so that's 0. Y is -3. Is -3 less than -2? Yes, it is. All right? So it works, doesn't it? So any point, okay, I just picked one. I just picked an easy one, that point right there, okay? But any point in that shaded region will work. You can look up. You can look up. Up here. There you go. So any point in this shaded region right here will satisfy these two inequalities. That's how a math teacher would say it. Okay, satisfies the inequality, or it just makes it work, right? Makes it work. Everybody got it? If you wanted to, you could pick a point like 0, 0. Let's pick 0, 0. We tried that earlier, right? We tried it with the red one. Does 0, 0 work for the red one? Yeah. So if I put a 0 in for this, 0 in for that, is 0 less than 4? Yes, it is. So it works. But what about the blue one? What if I put 0 in for that? 0 in for that, 0 in for that. So is 0 less than -2? No, it's not. Okay? So it works for the red, but it doesn't work for the blue. You got to find a point that works for both of them. All right? And everything that's shaded is kind of ugly shading, but you get the idea. All right? Make sense? Yeah. So we can go through the rest of them kind of quick now until the very last one. The last one's a little different. All right? Let's do this one, example 2. What do we got? 3x minus y is less than -3. And y is less than... What's that? Got a what?
You're saying you have to put the word solve in there.
Oh, I thought you said soft. I'm like, what are you talking about?
I'm not
Okay, solve. All right.
That's all the video.
Oh, no, I messed up on this. And it's, what's the other one? -y is less than -3x minus 3. Is that?
Yeah.
Okay, because I wrote something weird on my paper. I'll tell you what, let's do this. Oops. Let's get rid of this. Shh. See, I do one thing different, and you think that's time to to have a free time. It's not. Just pay attention the whole entire time. Even if I'm erasing something, even if I go to something else, if I go to my book or my notebook or anything like that, just hang on and just wait. Are those the two inequalities? Okay. So let's solve for y. Let's do this. Let's subtract a 3x from both sides. So I get -y is less than -3x minus 3. Well, they're not going to be the same thing. Wait a minute. Hold on.
No, they're not. Because the y-intercepts are just parallel. Yeah, but the y-intercepts different in both. What's up?
What were the are those the two that they gave me, or that they?
It is. They are.
Okay, hold on. Let's.
It's 3x
It's 3x
plus
minus 1 and 3x plus 3.
Oh, see, that's what I was asking.
One is plus 3 and one is...
Because I wrote it weird in my notes, and I wasn't sure which one's the original one. So this should be y is greater than, correct? Y is greater than 3x plus 3?
Yes. Yes. That's the final.
Oh my goodness. You're going to make me look. I didn't want to have to. All right, let me look. Let me look.
If you
y
put it in the
is y
intercept
less
form,
than
then
3x.
it'll be...
I know, but I want to know what the original one was.
No, you have the original one right.
I did?
Yes. That's what
All right, I'm looking. Y is less than 3x. No, it's not. The original was y is less than 3x minus 1.
No.
No, it's not.
I'm looking at it.
No.
It's example 2. I'm looking at it. It's 3x minus y is less than negative 3.
That's the final one. Like when you do all the math, that's the...
I'm telling you.
We're looking at example 2 also.
Let me see your book. Bring your book up, Simone,
That's what we're talking
or somebody.
about. So happy.
One of them is wrong though.
Y is less than.
That's the answer you're gonna get, but it's this.
That right there. That's your
this?
problem. That's the problem.
Yeah.
Y is less than 3x minus 1. That's what I was saying. So I was right. Again. That's why
I'm not wrong. He doesn't know the original problem.
that's why I get paid the big bucks.
That's what I said. I said the original.
All right, here we go. Now we got it. Shh. Guys, here we go. Man, you guys are crazy today. What's going on? Settle down. Up. Stop. Let's watch.
I had 4 sodas.
Okay, stop. I don't care. Stop. You're going to leave in a second if you're not going to pay attention to me. So that's the original problem. Okay, this one and this one were the two original things. All right, so I'm trying to solve for y. So if I want to get y by itself, what do I have to do? Divide by what? A negative 1. Now, what did I just do? I divided by a negative. What does that mean I have to do to this? I got to flip it, make it positive. What's this going to be? 3x plus 3. It's not the same as this. So they're not the same equations, are they? All right. So what I'm going to do, let's just put them in boxes. I'll tell you what. Let's just put them right next to each other, or right below each other. Like that. Okay. So this is what we're going to graph. Right there. Everybody got it? All right. Let me grab this graph right here. And scooch it over. Let's graph it and take a look at it. All right, y is greater than, let's do this in a different color, plus 3, 1, 2, 3. Slope is 3 over 1, 1, 2, 3 over 1. Now, somebody did say something, 1, 2, 3, 1. What did you notice about these two? They're not the same exact equation, but they are parallel. How do you know they're parallel to each other? Before you even graphed, you could tell that they have the same slope, right? So they must be parallel to each other. Agreed? And they will not intersect, correct? All right, this one just has negative 1, and it's the same slope. 1, 2, 3, 1. 1, 2, 3, negative 1. And then there's that, and there is, whoops. Mia, what is going on today with you? One, two. Oh, they should be dotted. Very good. Thank you for that.
Good job, Gio.
It should be dotted.
You're all like,
You're not funny.
All right,
Who are you?
I was off a little bit.
Funny looking.
Chandler,
Mr. Wilson, you're
please.
Wilson on everything.
All right, so there we go. And they should be dotted. That's correct. I'm not going to dot them because, as you saw, my dotted line was pretty horrendous, all right? But they should be, all right? They should be dotted. Absolutely correct. So since I shaded in yellow before, I'll shade in yellow now. So let's see. The red one was this first one right here, so it's greater than. So where is everything? Yeah, where's everything shaded? Now, it's so slanted. How do I know what's greater than? Is it up here or is it down here? It's basically to the what? The first one. This is the red one right here. That's the red one. Yeah, it's to the left. If you wanted to, you could pick a point. What's a super easy point to pick? Put a 0, 0. So that's 0, that's 0. Is 0 greater than 3? No, it's not. So it's not shaded on this side of the red. It's shaded over here. Okay? So everything's shaded there. All right? What about the blue one? Put a 0, 0 in for that. 0 and 0. Is 0 less than negative 1? No, 0 is not less than negative 1. All right, so where is it shaded? This way. So if it confuses you on which direction you shade, always pick a super easy number. If 0, 0 is available to you, definitely pick 0, 0. It's the easiest one to pick. Well, it will be. Well, it might go right through 0, 0, so it's not. Then pick something easy, like 1, 1, or something like that. Okay. Well, that's what I'm saying. Just pick one. If it goes straight up and down, then it's to the right. Okay, greater than would be to the right, less than would be to the left. So this says y is what? Less than the blue one. Do you see that? The blue one, it says less than. So this direction over here is less than. Okay? And that's your graph. You're done. Again, these should be dotted. All right? Okay, both of them have to be dotted. Now, is there a point that is that works for both of them? No, because if I pick a point anywhere in here, it's not going to work for this one, is it? All right. So if you look at it, that kind of makes sense, because if you got parallel lines, right, they're never going to intersect each other, right? So they're never going to have anything in common. All right. So that's one way to look at it as well. But this is the graph. Now, actually, they don't ask you to. Do they ask you to solve?
Yeah, but no.
Yeah. And is that what they say at the end? No solution? Okay. But sometimes they might just say graph it. All right. So that would be the graph of it. But looking at the graph, you can see there's no solution, because there's no point in one shaded area that's also in the other shaded area. We good? All right. Let's do another one before we get to the granddaddy of them all, as they say. I am not going to make you say consistent, inconsistent, because that was that second part of that. I'm just going to say, here, let's say this. Remember we did that consistent, inconsistent, dependent thing? Here's my personal preference. I've never really seen a book do that inconsistent, dependent thing. I mean, other books may do it, I guess. But if you just get, right, if you have two lines and you get one solution, you just write down whatever the answer is. Okay? Everybody with me? If you get two parallel lines, is there a point where they both share? No. So I would just say what? No solution. I think that's a better way to say it. It's easier to understand. And then what if you have this line and then you graph another line and it's the exact same line? You would just say, what are the solutions? Right, all the real numbers. That's right. All real numbers, or you could put that fancy looking R, all the real numbers, or you could put this kind of R. That means all the real numbers. Okay? So that's what I would like as an answer. Okay? Don't worry about the consistent, dependent, inconsistent thing. Just say this is no solution, this is all the real numbers, and then whatever you get for that. Okay? Everybody good with that? Good question. All right, so let's do another one. This one has an absolute value, and we've talked about absolute value in here, correct? You wouldn't believe how closely related the Algebra 2 topics that we've covered in here coincide with the pre-calculus topics that we're covering. All right, like this, the fourth example is very, very similar to stuff we did like in the first section of pre-calc. So a lot of this you're going to see again in pre-calc.
Is that example 3?
This is example 3. Example 3. And it says solve. I'll put solve for goodness sakes. Okay. Now, on this one, you don't really have to solve for y because it already gives it to you. Okay? So this is what we're graphing. Tell you what. What's that?
Aren't they both V's?
They are V's. That's correct.
One's 2 to the left of 0, 0. One's 1 below it.
That's correct. You got it.
You're getting smart.
Stole my thunder. You ever hear that phrase?
No.
Yes.
He just says what I was going to say. That's basically stole your thunder. All right, let's graph this. So it's absolute value. So what does it look like? It looks basically like a what? Like a V, all right? And it's a V. This thing right here, this plus 2, means it takes that V and it moves it where? To the left. So if it's inside the absolute value, if it's inside the function, all right, then we move it left or right. This looks like we should move it to the right, though, doesn't it? All right, but we actually do move it to the left because it's x minus however far we have to move it, okay? So it's x minus what? -2. So we actually move it to the left 2 places right there. And we do a V. How do I know how slanted that V is?
Look in front of the number.
It's just a 1,
It's just a 1.
okay? It's just a 1.
One X.
Yeah, so put a point here, 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 and then the other one is a -1 slope. Here, here, here. You can keep going if you wanted to. It is, this time it is solid, all right, because it's or equal to, both of them are. So that would look something like that. Let's go all the way off the graph there. And then this one would look like this, all right? It's pretty easy. So I'm going to graph. I'm not going to worry about the shading to the very end, okay? I'm going to graph the stuff first, and then I'll deal with the shading part. So what does this one mean? Look, this -1 is not inside the absolute value. So this means we move it what? Up or down. In this situation, we move it down. So we're going to move it down right there. Because normally it would be right there at the origin. But this means we just move it down 1. And again, we don't have to worry about the slant of it. Just 1, 1. Right there, right there, right there. Everybody with me? Okay, so that goes like this. Oops, come on. And this goes like this. Is that about right? And it should go like that. No, no. Close enough, whatever. All right. Too worried about being perfect on this. All right, now let's see what's going on here. So our shading. It says less than, so the red one is less than. So where is the shading? Is it inside the V? No, because that would be what? It'd be greater than. Okay, if we're not sure, we're looking at it like, oh, I don't really know if it's supposed to be inside the V or outside the V. How do you know? Pick a point. Yeah, choose 0, 0. That's an easy point. So 0, 0. 0 plus 2 is 2. Absolute value of 2 is 2. Is 0 less than 2? It is. So that means we're going to graph where? Or we're going to shade in, sorry. Where? Outside, okay, outside the absolute value. Does that make sense? Okay. We're not going to do it just yet. Let's look at the blue one. So the blue one says it's greater than. So guess where we're going to shade? Everything inside. So it's everything outside the red one and inside the blue one. So where is our shading going to be? It's going to be in between here and here. You see it? This is what's going to be shaded. So that's outside the red one. Why don't we shade out here? Because it's not inside the blue one, right? So it's got to be inside the blue one and outside the red one. And where does that occur? It only occurs in that area right in there. And again, you can always pick points to see what it's going to work. Now, let's pick 0, 0. 0, 0 should do what? Work for both of them, right? Should, because it's in the shaded area. Any point. Like I could have picked a point over here, whatever that is, like 4, 7, or I don't know what point that is, whatever it is. I could have picked that, but 0, 0 is an easy point to pick. So we already found out hold on. Yeah, that works. Okay. If I pick 0, 0, put a 0 in for this, is 0 less than 2? Yes, it is. Okay, put a 0 in for both of these. That's a 0 minus 1. That's a 0. Is 0 greater than negative 1? Yes, it is. So does 0, 0 work for both of them? Absolutely. Everybody good with that? Okay. Now, here we go. You good? All right. You do.
Yes.
You go potty.
I do, Gio.
I'm not going to put the graph just yet. You got your book?
Why are you talking like that?
Go potty like I did for you.
You want to come with me or something? Like,
All right, here we go. This kind of leads us up to something else. I don't know when or where they will hit the something else to this, but this is really close to what we did in pre-calc, I think just in the last chapter. And we're actually going to do a little bit more today with it in pre-calc. And it's a big word problem, and it's crazy. But this leads you up to it. So this is good. This is good for us to do. All right. Word problems are stupid. No. Now, look, I have skipped word problems because, to tell you the truth, it's really hard to explain and get people to understand them. That's part of the reason. We could do them, and then it takes like 2 or 3 days for everybody to start getting the hang of it, and it's just, it just seems like it takes so much time. But the whole reason we learn math is to do word problems. Word problems are what's important because that's why we learn math, in order to do them, okay? That's absolutely, because just doing these math problems, I mean, like shading in the absolute value, what's that got to do with anything? Well, but the word problems are what's really important. So it is important, okay? So here we go. Shh. So let's do example 4. Here's what they do. They give you 3 different equations. Actually, they're inequalities. So there's 3 of them this time, not 2. And we're going to start off the same exact way as what we've been doing. So the beginning of this really isn't anything different than what we've done today. That's supposed to be less than or equal to. It's kind of ugly. And then 2x minus y is greater than or equal to negative 4. All right, everybody good? Yeah, so let's work these out so that we can graph them. So what are we going to do? Solve for y. So here we go. Negative 4y equals negative x less than or equal to 12. Divide by negative 4, so we're dividing by a negative. So what are we going to do? Why did I put equals right there? What am I doing? I have no idea what I'm doing. Well, I do actually, but I sure messed up there. So this should be less than or equal. I don't know. And what's this? Plus 12. I don't know what I was doing. Lost in the moment, I guess. Here we go. So I divided by a negative, so I'm going to get y is what? Instead of less than or equal to, it's going to be greater than or equal to. What's this going to be? Positive. We did this earlier, 1/4 x, and this is going to be minus 3. So that's one of the things that I'm going to graph. Okay? Everybody go to that? This one's a lot easier. We just... All right, so that's another one that we're going to graph. And then we do this. So let's do negative y greater than or equal to negative 2x minus 4. Divide both sides by a negative. So if we divide by a negative, we change the inequality. That becomes 2x. This becomes plus 4. And we're going to graph that one right there. Okay? So that wasn't hard. Everybody's got that down. Now we'll put our graph here. Can it fit? There we go. And that's good enough. I'll bring this down a little bit. Then I can lift it up. All right. So let's graph all 3 of these. Let's do this one. Let's do this one in red. We'll do this one Might as well use blue again. And then we'll do this one. Let's do it in green. Okay? So let's do it. -3. 1, 2, 3. Slope is 1/4. 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. Let's go down here. 1, 1, 2, 3, 4. Good enough.
Then we need the rules for all like the slopes and stuff.
I did. I made them all up. Rene Descartes had a lot to do with it. Remember talking about Rene Descartes?
Yeah, wasn't he the guy who made the coordinate plane?
Yeah. He's not the only one. A lot of people came together and did this kind of stuff. All right, let's not worry about that. Let's worry about doing this problem. Gio, please.
Make sure you keep the door open.
Okay, there's 2. And what's the slope? It's -1. So that would be here, 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 here. Now, see what I just did? See where it intersects? That's going to be very important in a little bit. All right, so that goes up like this. This goes down like this. And we got one more. Got a third one to do. All right. And what's this? 4 is y-intercept. 1, 2, 3, 4. And the slope is 2. So I go up 2 over 1. Let's go down 2 to the left 1. Down 2, left 1. Down 2, left 1. Down 2, left 1. Ooh, right there. That was kind of important because I'll show you in a second. The intersection is going to come into play here. Everybody watching? Okay. Now, let's talk about the shading. Let's shade in yellow just like we did before. All right? So, it's greater than the red one. So, it's everything above the red. It's less than the blue one. So, it's everything down here below the blue one. Everybody with me? So, it's everything above the red, below the blue, and what? Below, or we could say maybe to the right, I guess, however you want to say it, right? Below the red one. So, what's shaded in? The triangle itself. Right, so that triangle right there is what's shaded in. Okay? I can't. It's good enough. That's shaded in. All right, here we go. Shh. Listen. Now, that was good enough. Okay, but they're going to ask you to do something and go a step further than what we did. Okay, the stuff that we did earlier, we would be done right now. Okay, but what they're going to do is they want you to find the vertices. Find the point for the vertices. Now, a couple of these are really easy. Shh, everybody look up here. Come on, I only got a couple minutes. Look, find the vertices. These vertices tell you something very important about the information that we're doing here, all right? And you'll learn later. I was working on it this morning, and I was watching a guy doing a video on this. And really, it's really kind of cool where this helps in real life. It really does. It can really help in a real life situation, like if somebody owned a business or something like that. Anyway, let's talk about it. So I want to find the vertices. So that's a vertex right there. That's a vertex right there. And then what? Now, 2 of these are really easy to find. Which 2 do you think are easy to find? Yeah, the bottom 2 down here, because it crossed right exactly at it, okay? So let's find that one. That would be what? 1, 2, 3, 4. 1, 2, 3, 4. So -4 would be one vertex. Agreed? This one would be an easy one. 1, 2, 3, 4, -2. So 4, -2 would be another vertex. The problem is finding this. Look how it's kind of in between. Is there any way you're going to guess and get it right? No. So what would you do? It's the intersection of the green one and the blue one. So what do you think you're going to do with those 2? Well, you could do elimination, or I would just do substitution. Watch. I'm just trying to find a point. So watch. Listen. So what I can do, pretend it's just y equals and y equals. Don't ask me why, just pretend. Okay? If y equals this and y equals this, then what? 2x plus 4 must equal what? -x plus 2, because they're both equal to y. Let's solve for x. Let's do it real quick. Hang on. Add an x, what do you get? 3x. Subtract a 4, you get -2. So x is negative 2 over 3. Now you can take that negative 2/3, put it into either one of these. It doesn't make any difference. And then you can solve for y. Once you solve for y, I'll do the math for you. You get 8/3. So what's your other vertex then? It's negative 2/3, what? 8/3. There's no way in the world you would have guessed that, would you? All right, but that's how you can find that vertex. That vertex is very important, okay? It gives you some really good information. We'll talk about that another time. So you are doing numbers 5 to 16 for homework, okay? So it's section 3-4, section 3-4, 5 to 16, it's page 126. Now you can go.
Okay. Oh my gosh.
There it is, right there.